All right, guys. So here's some homework help. I think the square roots is what's like maybe scaring you guys a little bit. Remember what we did in the fall semester, guys, when we had linear combination of cosine and sine, and we wanted to turn that into a single cosine. We did this. We did this. We said a cosine theta plus b sine theta equals capital A cosine theta minus d, where D is equal to arctan of B over A, but you have to check what quadrant you're in, right? Check quadrant. I can't spell. And capital A is equal to the square root of A squared plus B squared. So I think some of you guys are just forgetting that's what we did in the first semester. And you see square roots and you guys get scared. We want to turn this into a single cosine with a phase displacement, guys. So you've done this before. This is just some positive number, and square root of 6 is bigger than square root of 2, so that's another positive number. So if you do your hack, you're in quadrant 1, guys. You're in quadrant 1. So if not to scale, I'm just drawing something, so I'm going to put not to scale. So this x value here, this is like an x value. Excuse me, it's in front of the cosine, x. This is like a y value, it's in front of the sine. So it's like this is square root of 6 plus square root of 2. And this guy right here, the vertical displacement, is square root of 6 minus square root of 2. So your amplitude, you're just going to do Pythagorean theorem. Your amplitude is that guy. And the angle D is the distance from the x-axis to that curve. So angle A, or angle A, side hypotenuse, or side A, or hypotenuse is better because it's a right triangle. It's just the square root of square root of 6 plus square root of 2 squared plus square root of 6 minus square root of 2 squared. And yeah, so you take your calculator and you're going to go square root, parenthesis, square root of 6. I have to get out of there. Come on, buddy. There we go. Oh, no. Plus square root of 2. Let me get out of there. Close it, square it. Plus parentheses square root of 6 minus square root of 2. Close parentheses, put a square on it, and voila. Now, you could always just, if square roots give you a hard time or you don't want to mess with square roots, you can say square root of 6 plus square root of 2 on the outside and then just assign it a letter. You know, I mean, if you want to assign this letter B and then do square root of 6 minus square root of 2 and assign another letter like letter C, alpha C. And then you can just go square root of b squared plus c squared plus c squared. And you'll get the same thing. So if you're scared of square roots, just do that. So there's your amplitude. So your amplitude is 4. And then your angle, this is in degree mode. Do this in degree mode. So your angle is just going to be this guy over this guy. So arctan of square root of 6 minus square root of 2 over square root of 6 plus square root of 2. Now remember, I already have this in my letters, c over b, right? So I can just do that. I can just go c over b. So I can just go arctan alpha y equals, you don't even need the fraction thing if you don't want to, c over b. And voila. There it is, 15 degrees. 15 degrees, see? And there it is, guys. So this equation is just going to be y equals, let's see, where's my amplitude? 4 cosine parenthesis theta minus 15 degrees. And it is equivalent to this. So watch. If I have my calculator, now remember, in my calculator I already have b, let me scroll up. B is 6 plus square root of 2, and c is 6 minus square root of 2. So check it out. I'm going to go here. Oh, that's from the other problem, the last problem that we did. All right, so I'm going to go, let's see, I'm going to go alpha b cosine x plus alpha c sine x. That's the original. Notice it's in blue. And I'm going to type in my new equation here, 4 cosine x minus 15 degrees. And I'm going to make sure that I'm between negative 360 and 360. Yep. And the amplitude, I don't need to go all the way to negative 10. I can go like to 7, negative 7 and 7, because the amplitude's only 4, right? Oh, I said 4. I said, okay, 7. There we go. All right, graph. There it is, guys. See, same graph. If I go to the table, you can see y1 and y2 are the same. So there it is. There you go. It's their equivalent. So it's just something that we've already done, guys. So don't freak out too much. See, this one you can tell your amplitude is going to be 5. It's a 3, 4, 5 triangle if you do the little hack. So yeah. And then these I'm not worried about. These, you guys have been doing those. That's just what we did. Example 1 and the very last example, right? You're just going to use your formula. Cosine A minus B equals cosine A cosine B minus sine A sine B, where theta is your A and 30 degrees is your B. And then just look at example 1 or the last example we did on the notes. It's verbatim. If you have trouble with it, just let me know and we'll go over those again. Let's see. Number 8 and number 9, that's just what we did a little while ago, algebraically. I'm already in degree mode, guys, so I'm just going to do number 8 and then let you guys do number 9. So again, it wants you to solve algebraically. You can't do it the way it looks right now. You need a single cosine with a face displacement, or sine if you know how to do it with sine, but with cosine's better. Single cosine with face displacement. So let's do that. So 5 and 7, 5's in front of the cosine, so that's like an X. 7's in front of the sine, that's like a Y. Here's my hack. 5, 7, point. That's the point 5, 7. Draw a point from the origin. This is 5, this is 7, so I need my amplitude, and I need this angle D. All right, so amplitude is nothing more than the square root of 5 squared plus 7 squared, and then angle D is equal to arctan of 7 over 5. And I'm already in quadrant 1, so I don't have to do any more adjustments. So let's see what this is. 25 plus 49. Let's see. I said 49 and I wrote 45. That's 49. So that was 50. That would have been 75. So 74. So square root of 74. And arctan of 7 over 5. So I'm going to take my calculator. I'm going to go second quit, second arctan, 7 over 5. So this is 54.462. So 54.462 degrees. So there it is. So this is equivalent to square root of 74 cosine parenthesis theta minus 54.462 degrees. Close it. And I'm still equal to 3. So now what you're going to do is solve for theta. Solve for theta. And we've done this the first semester. This is all we did in the first semester. Not just this, but we did a lot of this. So divide by square root of 74, divide by square root of 74. So then you have cosine, parenthesis, theta minus 54.462 degrees equals 3 over square root of 74. You could rationalize it if you want, but I would leave it alone. And then you're going to do arc cosine. So you're going to have theta minus 54.462 degrees equals plus minus arc cosine of 3 over square root of 74, close, plus 360n. Now remember, guys, in case you're asking why the plus minus, so here's a side note. If I were to tell you arc cosine of, I guess let's just do the square root of 3 over 2. You would tell me pi over 6, and another answer is negative pi over 6. See, so instead of saying, like giving me, plus 2 pi n, right? Pi over 6 plus 2 pi n, and then equation number 2 to get the other one is negative pi over 6 plus 2 pi n. But how do we get both of them in the same time at one time with those plus minus? See, here's the positive one, pi over 6, and here's the negative one, negative pi over 6. Cosine of negative pi over 6 is square root of 3 over 2, guys. So I want all the answers in quadrant 1 and in quadrant 4. Because those are my answers, where cosine is square root of 3 over 2. And that's what it means. It's just inverse cosine, right? Arc cosine. So remember, inverse is your x turns to y, your y turns to x. So, and if you have gaps in your algebra, this is going to be confusing for you. You're going to be like, what are you talking about? And I know, I put degrees here and I put radians here. Maybe I should have put 30 degrees here in this one since we're in degree mode, and then negative 30 degrees here. This is just an example, guys. This is just a side note. So positive 30 degrees gives you square root of 3 over 2 for cosine. Cosine of 30 degrees is square root of 3 over 2. And then cosine of negative 30 degrees is also square root of 3 over 2. So that's why we put the plus minus there. Hopefully that made sense to you. If it didn't, come in and we can talk about it, guys. I'll play it back to make sure I didn't say anything wrong in a little bit or as soon as I finish this up right here. All right. Last thing, all we got to do now is just move this 54.462 right in front of that. So theta equals 54.462 degrees plus minus arc cosine of 3 over square root of 74 plus 360 degrees n. And then from there, you get your answers, guys. From there, you get your answers. I'm going to write my answers right here in the middle. Theta equals, and if you want, you can split this up into two equations, one with the plus, one with the minus. I'm just going to go ahead and take care of it right here real quick. So I'm going to go, let's see, I get that answer. I'm going to go plus arc cosine of 3 divided by, I believe it was square root of 74. Sorry, guys. Square root of 74. And let's see what we get. And I want all my answers. Notice that it says here that I want all my answers between 0 and 360. So I don't have to worry about adding 360 unless it's a negative, but we'll find out right now. So 54 points, so there it is. I'm going to push enter. 124, so that's one answer. So I'm going to go theta equals 124 point, and I already forgot, so let me go ahead and write it out. 0518 if I truncate it. 0518 degrees, that's one. And I'm going to have one more. So I guess, I was going to write theta 1, theta 2, so I'll just put comma. So now I'm going to do the minus. I'm going to subtract, and then whatever number I get, it's going to be a negative number. I'm going to add 360. So here we go. I can't see, I did a mistake and I put answer in here. If I do that again, it's going to count the 124 as an answer. So I'm going to come up to the 54 and go minus arc cosine of 3 divided by square root of 74. So I'll just, I could add to plus 360, but I want you guys to see what this is. It's going to be a negative number. See, that negative 15. And then when I add 360 to it, I'll be within the domain. Plus 360. And then voila, 344.8727. 344.8727 degrees. And I know what you're thinking. Maybe you're saying, Chab, I could have just solved this with a calculator. But it does say to solve algebraically. But it is good to check. So I would type this guy in Y1 and type the 3 in Y2, or use Wolfram Alpha. It doesn't matter to me which route you go as long as you know what you're doing. So if I were to take my calculator and I were to go to Y equals and type in 5 cosine x, close it. Let's see, what do we have in plus 7 sine x? So plus 7 sine x, close it. And then I were to type in 3. I better get those two answers, right? So I'm going to push graph. And, actually here it looks like I have 3 answers. Oh, that's because I didn't change my domain. Remember, it was from 0 to 360. 0 to 360. So there it is. And I guess if I want to see the whole graph, what was my amplitude? Square root of 74. So just a little, I'm just going to put negative 9 to 9 because, negative, so we can see everything. Negative 9 to 9. All right, graph. And there it is, guys. So look, check it out. Second, calculate number 5, enter, enter. I scroll to this guy, push enter. 124.051, it works. Second, calculate number 5, enter, enter. Scroll to this dude over here. Push enter. And there it is, it works. All right, guys. I guess, I did this homework does have, it does say linear combination and composite argument. I did the questions that I think you guys are going to have trouble with, but let's just do one more. And I guess we'll do question 4 because we already got it kind of started there. So let's just do one more. So all I'm doing on question 4, guys, is I'm just applying this formula here that we derived in class. So let's go ahead and do that really quick. I'm going to put a bracket around this. So that theta, like we said, is like A, and that 30 degrees is like B. So 10 bracket, and I'm going to write, look what it says here on the right-hand side. Cosine, cosine, cosine A, cosine B. So I'm going to write cosine theta, cosine 30 degrees, and then there's a plus symbol, so plus sine theta, sine 30 degrees. And there it is, and then I'm going to distribute But the cosine 30 and the sine 30, that's an actual number, guys. So I'm going to write 10 cosine 30 degrees cosine theta plus 10 sine 30 degrees sine theta. And then cosine 30 degrees, we know what that is. That is square root of 3 over 2 with a cosine theta plus, and then we know that sine 30 degrees is half, right? So 10 parenthesis half sine theta. So finally, you get your answer, which is this. 2 goes into 10 5 times, so 5 square root of 3 cosine theta plus half of 10 is 5, so 5 sine theta. And there it is, guys. And yes, this is equivalent to this. And let's test it. Let's test it. So I'm going to go into my calculator again. And I'm going to click y equals clear, clear. And I'm going to go 10 cosine x minus 30 degrees. And because I'm in degree mode, right? Push enter. And on y2, I'm going to type in my linear combination of cosine and sine. 5 square root of 3 cosine theta plus 5 sine theta. Why do they call it linear combination? Because there's a plus symbol there. And none of these cosines or sines are squared. So 5 square root of 3 cosine theta plus 5 sine theta. So I'm going to come back. 5 square root of 3 cosine theta plus 5 sine theta. It's going to go really fast. So here it is. Well, I guess let's make the window go to negative 360 to 360. All right, here we go. Yep, same thing, guys. See? If I look at the table, there it is. Same values. So hopefully that made sense. I hope that helped you out. If it did, hook it up with a thumbs up. And let me know. Let me know what's giving you guys issues. All right. Talk to you guys later. Bye.